5. First of all, it says G is of x is the area under this from 1 to x. And so if we find the area under this curve from 1 to 1, that's no width, and so this has got to be equal to 0. Now, the area under the derivative, so this is the derivative, and so if I put in 1, it's just going to be 1 squared minus 2, which is minus 1. And if I put in 2, 2 squared is 4, minus 2 is 2. Now, if I have a constant to x, integral of it, then I integrate this. The derivative of negative cosine u is sine u, and we're going to evaluate from 0 to x, and so this is going to be x in here minus cosine of x, and then minus cosine of 0, and the cosine of 0 is 1, so we're going to get minus cosine x minus a minus 1, which is plus 1. The integral of e to the negative t is negative e to the t, evaluated from x to 0, so I put 0 in and I get e to the 0, which is 1, negative, so I get negative 1. Then I put x in there and I get minus a minus e to the x. And now if I integrate with respect to t, integrating t, that's 1/2 t squared, evaluated from 1 to x squared. So I put x squared in there and I get 1/2 x squared squared, which is x to the 4th, minus 1 squared is 1 times a half is a half. Now, if this is f, the integral of this would be the integral of this, and so if I change the x to t cubed plus 1 dt, if I integrate that with respect to t, then t would have to go from something that makes 0 to some x, and that would make it be a function of x. So I can just put a 5 where it's 0, and there's what f of x would be, because I would just put x in for that, and the f of 5 is 0, so that's going to be gone. So there's the answer. And I'm doing a similar thing here now with secant, so it'd be capital F of x would be the integral from 0, which makes 0, to x of secant, the integral of secant of t dt. And and I forgot to say the derivative dx, the derivative of the integral, no, I don't need to take the derivative because I just need the capital. So that's what that's going to be. Okay, now here we got the derivative of the integral, so that means I just put x in place of the t's. And so that's x to the 5th minus 9x to the 3rd. Okay? And here I got to go, okay, so now let's look at this one a little closer. So if this is small f of x, or f of t, then its integral would be capital F of t, and evaluated from 1 to 1 over x, which would be capital F of t, capital F of 1 over x. Oh, yes, that minus capital F of 1. But it says take the derivative with respect to x. So I got to take the derivative of this with respect to x. So I have to take the derivative of this with respect to x and the derivative of all this. And so the derivative of this would be little f of x, or f of t, and but then the chain rule, that would be of f of t times the derivative of the inside, derivative of 1 over x, x to the minus 1 is 1 less, minus 1, x to the 1 less minus 2. And then the derivative of constant is gone, and so we have, and little f again was cosine cubed of the t, or what we're putting in, 1 over x times the derivative of the 1 over x, which is minus x to the minus 2, which means down x squared underneath. So, shorthand is I just put 1 over x in for the t times the derivative of 1 over x. That's kind of the rule, so that can be the shorthand for doing this one. So it's going to be from a constant to something in the ds. So I just put cosine s in for u to the fourth times the derivative of the cosine s, which is, derivative of cosine is negative sine of s, times the derivative of s, which is, we're taking with respect to s, so we're done. That's it. Oh, wait a minute. U to the 4, yeah, that's right, just plugging it in there, because I'm taking the derivative of the integral, so it cancels out. So it's just that. So here, this one, I'm going to have to split it up. I need to go from integral from negative u to 0 of the square root of x squared plus 1 dx, and then take the derivative with respect to u, plus the integral from to some case, it's some number, and then from that number to 3u of the x squared plus 1 dx, which, if I turn these over, which just makes a negative, then I can just put negative u in place of the x. So this would be negative u in for the x would be negative u squared, or u squared plus 1, because negative u squared is just u squared, square root, times the derivative of what this would be at the top, which would be negative 1, but I have to do the negative of this because these limits are backwards. I have to reverse these, put negative u up here, which means I put a down here. Now it's in the order I need. Changing the limits changes the sign. And then if I'm taking the derivative of negative u, I get another negative. So I get a negative, canceling out. So I just got square root of u squared plus 1 plus, and if I go from some constant to 3u, I got to put 3u in for the x. So square root of 3u squared is 9u squared plus 1 times the derivative of what I'm putting in, which is a 3. Oop. Got off the paper there. Okay, so I split this up into two integrals from negative u to a, and then I flip the limits, so that makes it negative. And then I put in the negative u in here and squared and got that. And then times the derivative of negative u, which is a negative. So I have a negative of the derivative of a negative u, which is negative 1. So that becomes that. And then if I go from a to 3u, I put 3u in there, get 9u squared, times the derivative of 3u, which is 3. And I didn't have to flip any units, so that's the